guys, here today for our air pollution lab, particulate matter. My question to you is, how does particulate matter affect temperature change when it occurs? Particulate matter, carbons, hydrocarbons, factories burning coal, running fuel, etc., fumes from cars, all this pollution, little teeny tiny bits of hydrocarbons burning, getting up into the air. How do they affect temperature around us? So you're going to come up with a hypothesis, but in order to do so, you kind of need to know what we're doing. Now, I don't have the experiment all set up yet, but real simply, what we're going to do in here is we're going to light a little bit of incense. That incense is going to release some hydrocarbons into the air, smoke, just like pollution. So this will represent a city with a lot of factories and high pollution level. This will represent a city that does not, so fairly clean. I've got temperature set up. I've got to get my light set up on here, so I'll have a heat source like the sun. What we're going to do is we're going to flip the light on for 10 minutes, represent the sun coming out, and it should heat up our cities, right? And we're going to note what happens to the temperature. Then I'm going to turn the light off, and for 10 minutes it's going to cool, and we'll see what happens to our temperature. That's the basic setup. What do you think will happen with a city that has pollution versus a city that doesn't have pollution? Now let me warn you off the bat, it's probably not going to be super dramatic changes. When we talk about climate change and temperatures, they're pretty small. So don't get too out of whack with what you're thinking. Also, when I look at these thermometers, they're not calibrated perfectly. So the one in here starts off just 1 degree higher than the one in here. So when it's all said and done, we want to look at the temperature range. Like this one started at, say, 25 and it went up to this temperature. And this one may have started at 24, but it went up to this temperature. And then when it cools, the same thing. Remember, I'll let you know ahead of time, but these thermometers aren't exactly the same, even though it's the same temperature. So we have to go off the comparison, what this one is starting with and what this one is starting with. Well, that's pretty much it for the intro. I'm going to go ahead and get the experiment all set up, and I'll see you back here in just a bit, and we'll run the experiment. All right, I want to talk through the first couple of minutes of this, and then I'll just interject the actual temperatures. First off, this was starting at 23 centimeters in the one with the pollution, and it was starting at 22 with the one without pollution, just because these thermometers are not exactly calibrated, so we have to take that into account when we talk about the temperatures rising, falling, or whatever they do. Now obviously we're coming up here on 1 minute, and I will track for you what the temperatures are at each minute interval. So right here at 1 minute, well, I'm already at 25 for pollution and 24 without. Now, if you notice, really, in the one with pollution, well, this acts like a thermal inversion. The warm air rises, but as it hits the top of the beaker, it doesn't have anywhere else to go, so the pollution begins to fill up the beaker. This is what happens in cities where a temperature reversion occurs. Typically where we have mountains on several sides, the air coming up over the mountains is warmer than the air rising. There's nowhere for it to go, and the pollution begins to fill up in the valley below it. Okay, 2 minutes. I'm at 27 for pollution, 25 without. I think I'll pretty much go radio silent from here on out. That way we can probably speed the film up a little bit, and I'll just slow it down at the minute intervals so we can note the time. Alright, we have 28 for pollution and 26.5 without. Right at 29 for the pollution and 28 without. With pollution, 28 without. With pollution, right at 30 and about 29. Just a hair above, and 29. We'll call it like 30.2. Okay, pollution, we're going to call it 30.5 and 30 without. Alright, 31.5 with pollution and 30 without. Alright, with 15 seconds to go, a couple of things I'm going to do. It's 32 with pollution and is stable at 30 without. What I want to do now is simulate nighttime, if you will. So we're going to stop, reset, start again, and now it's nighttime. So we're going to go with what we ended with, which was 32 and 30. And we'll take a look after 1 minute. Now the factory's shut down, right? It's closing time. Everybody's headed home. We're not producing the pollution anymore. It's just out there in the air, right? Some is settled. We can see some is still in there. Let's see what effect it has on now that it's cooling, that our heat source has set, or in our case, obviously, we've just turned it off. So right after 1 minute, we're already down to 30 in the pollution, and we're down to, we're going to call it 28.5. After 2 minutes of cooling, I am down to 29 degrees, and I am down to 27. 3 minutes in, still 29 degrees, and we are at 27. At the 4 minute mark, we could probably call it 28.5 and 26.5. The 5 minute mark, 28.5, 26.5. Six minute, still got 28.5, 26.5.